All right, welcome Year 12s. Exercise 3G, question 9. Show that PQ is 4 times cos theta. Now there's two ways you can do this that I can think of at least, possibly 3 actually if you use cosine rule, but I didn't try that. I'm just going to try and redraw the triangle outside of the circle because I need a bit more space. Now that's 2 kilometers there, that's 2 kilometers there. Some of you might know this property of circles, that this angle in here is actually a right angle. Right, so if you have a diameter of a circle, any point on the circle where you've drawn lines from the edge of that diameter will actually make a right angled triangle. But I'm going to assume that you didn't know that. Okay? What I'm going to do is split the triangle in half, like so. All right. And the reason I can do this and know that it's right angles here is because this triangle that I've pulled out of the circle there is isosceles. Isosceles, it means that that would be theta. This angle here would be 90 minus theta. That would be 90 minus theta. That would be theta. All right, but really, I don't need to worry about that. What I need is this little length here. All right, and if you recall that cos theta equals adjacent divide hypotenuse, we're looking for the adjacent. The adjacent is cos of theta times the hypotenuse. Hypotenuse is 2. So we have 2 lots of 2 cos theta, and that equals 4 cos theta. Okay, so that is part 1 done. All right. Now let's just flick back to the question. There it is. So I've just done A. Show that PQ is 4 cos theta. Show that the time taken. Oh, the time. All right. Now, Hugh's journey. What's happening with Hugh is he's rowing a boat. This blue is a lake. He's rowing a boat from P to Q, and then he's walking. Right. He rows his boat at 3 kilometers an hour, and he walks at 6 kilometers an hour. It's going to let me draw, good. So he rows at 3 kilometers per hour, and he walks at 6 kilometers an hour. Okay. And in my mind, I always remember that speed is distance divide time, because I drive a car and the car's speed is in kilometers per hour. Distance divide time. So that's really easy to remember, that equation, because we use that all the time, kilometers per hour. And then from there I can figure out what time would be. I'd have to swap these two, multiply both sides by time, then divide both sides by speed. So it follows that time equals distance divide speed. Okay. Now I've already got a distance for his row. It's 4 cos theta, right? So the time it takes Hugh to row, time for rowing, would be the distance, 4 cos theta, divided by his rowing speed of 3. All right. Now, the distance for the walk, which is around here, There's this little walk. Great job, Hugh. I don't know that distance yet. Okay? I need to think about this as a slice out of my circle. Okay? So that QR distance, Q across to R, and that sort of curve journey, would be a slice of circle. It would be some angle divided by 2 pi radians, the distance around the circle, okay, multiplied by the formula for circumference of circle, which is 2 pi r. So it'll be the circumference of the circle, 2 pi r, times the slice of circle that I'm looking at, right? But to get that slice, I need to know this angle in here. I need to know what is this angle, right? Okay, well, if that's theta, and this one in here is theta, and this whole triangle adds up to 180 degrees, then inside here, this angle has to be 180 minus 2 thetas, right? Let's see if I can write really small. It might get, oh, where can I put this? I might put it here actually. 180 minus 2 thetas, and that goes in here, right? Well, if that's 180 minus 2 thetas, where over here must be the 2 thetas, right? Because all of this is a straight line. So we've got this straight line here, yeah, saying this is 180 minus 2 theta. That would have to be the 2 theta, because all of that is 180 degrees as well, right? It'd be like, okay, 180 minus away this. And what does it leave us with? Well, 180 minus 180 is 0, and then I've got minus, minus, so I'm left with 2 theta. Okay, get rid of that, don't need it. And that gives us our slice of circle. So the distance would be 2 pi, now what's the radius? 2, which is just 4 pi, times the slice would be 2 theta divided by 2 pi, because we're working in radians, and the distance around this circle is measured in radians 2 pi, right? They're going to cancel, boom, ba-dum, and you'll be left with 4 theta, okay? So this distance is 4 theta. But what about the time? The time to do Q and R would be the distance 4 theta divided by the speed 6, and that equals 2/3 theta. All right, so the time for the whole journey, all right, time equation, which we'll probably just call T, equals that 4 cos theta on 3 plus 2/3 theta. All right. So for B, I'm going to erase my working and write this as an equation up here. T equals 4 cos theta on 3 plus 2 theta on 3. Okay. Next, part C. Part C says find theta such that the derivative of my time function equals 0. Right, okay. I'm not sure if this is a max or a min yet, right? But what we need to do is differentiate. So we need dt on d theta, okay? So we got 4/3 and the derivative of cos equals sine. In fact, it equals minus sine. We've got minus, all right, plus 2/3 theta. What's the derivative of that? 2/3. Now, treat your thetas like they're x's, yeah? If you had 2/3 x, you'd know the derivative of that 2/3 x was just 2/3, right? Okay. This will equal 0 when? When will this equal 0? It will equal 0 when, maybe we could have a common denominator here, I suppose, which might be a good way to go. Yeah, all right, let's try that. So if we had all on 3, minus 4 sine plus 2 equals 0, right? So this is my derivative equals 0 when, okay? And I shouldn't really be writing that 0 up there. It's just so I can think about it. Well, therefore, right, we would have minus 4 sine theta plus 2 equal to 0. Because how am I going to make this fraction 0? I just need to make the numerator 0, just the top. Okay, therefore, sine theta has to equal 1/2. Now, are we following all of that? If I took this 2 over here, it would be a minus 2, right? Minus 2 to both sides. Then, with minus 2 over there, I would divide by minus 4. What's minus 2 divided minus 4? It's positive 1/2. This is positive 1/2, right? Inside of a unit circle, where is sine equal to 1/2? What's here, right? The cos value is √3 on 2, but the sine value, or the y coordinate, is 1/2, and what's this angle? Okay. The angle there is pi on 6, right? So it follows that. Therefore, now I'd normally work down the page, but I've run out. Theta equals pi on 6. You might be thinking, could we include the 5 pi on 6? Because over here, the sine value is also 1/2, right? If I look at this angle all the way around there, that's 5 pi on 6, yeah? And the sine value there is 1/2, but it doesn't make sense to use an angle that's 150 degrees, does it? Because look at these thetas. They cannot be more than 90 degrees, okay? So there's only one valid solution, and it's the first one. Theta equals pi on 6. Now, let me reread the question. Find theta such that the derivative equals 0. Well, we've already done it. But it would be nice to look at a sine diagram and find out whether this is a maximum or a minimum. Okay. There's pi on 6. Realistically, we're only going between an angle of 0, so that's all cut out, and 90 degrees, or pi on 2. Pi on 2. So do we have positive here or negative? Do we have positive in this region or negative? Well, the easiest value for me to test is actually right on the limit, 0. Okay. If I go back to my derivative equation, if I make sine equal to 0, the whole thing's 0. So that all becomes 0, and I'm left with a positive 2/3. What about over here? Probably the easiest value to test is pi on 2. Well, you could look at pi on 4 or pi on 3. Sine of pi on 2 is 90 degrees. So pi on 2 equals 90 degrees. Sine of 90 degrees, or sine of pi on 2, equals positive 1. So if that is positive 1, then I would have minus 4 on 3 plus 2/3. That would give me minus 2/3. This is a minus number. We actually have a maximum time when that angle is pi on 6, right? So, this actually brings us on to the last bit of the question, E. It says, what route should Hugh take to travel from P to R in order to get the longest time? Right, the longest time. Right. The longest time, right, is when theta was an angle of pi on 6. So he needs to row from P to Q at 30 degrees or pi on 6, and then he needs to walk. You could find that time, right? We have an equation for time here. We could plug pi on 6 into that equation and find out what the time is. It doesn't ask me to do that, okay? But I think for the second part of E, I will do that. Because in the second part of E, it says, what about the shortest time? And this is a really important point. So this is E, part 2. What is the shortest time? The really important idea here is that, these emails, I'm sorry about this, because you've probably seen them on your screen. My apologies. Anyway, the shortest time. It's not at pi on 6, is it? Okay? And the important concept that I'm trying to get to is that we can often have optimal solutions at our boundaries. So I think maybe the shortest time is here when theta is 0 degrees, right? Maybe we've got theta equal to 0, or maybe theta is pi on 2, right? So don't forget that you can get an optimal solution at a boundary, right? Because this shortest value will not be a minimum, right? Okay. So if we make it 0, what would happen here? We'd have 4/3, right? What would the time be if theta is 0? Well, cos of 0 is 1, so we have 4/3. These are in hours, okay? And this would all just equal 0, okay? But what about if the time was pi on 2? What would we have then? Right. Well then, this all becomes 0, and we'd have 2 times pi on 2, which is just pi, divided by 3 hours. Right? Now, it's worth noting, and by the way, that's the answer. Right? This one here is shorter. If you took pi, it's only just over 3, 3.14, divide it by 3, you're at, somewhere around the 3.05, sorry, my bad, 1.05 mark. So it's shorter than 4 on 3 hours. So this is the answer we're looking for. Let's just think about what it means. If the angle was 90 degrees, you're not doing any rowing at all, right? There's 90 degrees there. What you're doing is you're walking the whole way, right? If your angle was 0, you'd be rowing the whole way straight across. That'd be the shortest distance. But because you only row at 3 kilometers per hour, it's not the shortest time. Okay? The shortest time would be to walk the entire way at 6 kilometers per hour. Okay, thanks guys. Hopefully that was helpful. Peace out.